Okay. So let's start, guys. Guys, in yesterday class, we are discussing the packet flow, right? Everyone. In previous class, we discussed the packet flow. We are discussing, I think, packet flow in the same subnet, right? So let's continue. Guys, we have this topology, okay? And in this topology, we are going to discuss packet flow in the same subnet. Packet flow in the same subnet means here we are using the switch. And these are the end users that are connected with this PC, with this switch. And here we are using the IP address 10.1, 10.3, 10.4, and 10.2. Done. So here on all the PCs, we are using which network, guys? 10th network. It means you can say all the PC is in the same network. Either you can say all the PCs in the same network, or either you can say all the PC in the same subnet. Getting my point? And we will ping from PC1 to PC number 2. So here we are going to discuss how actually the packet will flow from PC1 to PC number 2. And this flow is known as packet flow in the same subnet, because packet is here flowing inside the 10th network only. Getting my point? We are pinging from 10th network to 10th network. Getting my point? Our source is also in the 10th network and our destination is also in the 10th network. Getting my point? So that's the reason it is known as packet flow in the same subnet. I hope this is clear to all of you, everyone. Understand? Now, guys, please focus here. For example, on PC number 1, we write the command ping 10.0.0.2. So when we write ping 10.0.0.2, what will happen? In previous class, I think in yesterday class, we already discussed about the ARP exchange, right? Everyone. And I hope everyone know how actually the ARP will exchange between PC 1 to PC number 2. Done. I hope these things you guys know, right? Now, when you guys will ping from 10.0.0.1 to 10.0.0.2, PC number 1 will generate one packet, and the name of that packet will be, guys, which packet, guys? ICMP packet. Right now, everyone. Which packet, guys? ICMP packet. Clear? Now, why it will generate the ICMP packet? Because ping is a utility that use which protocol? ICMP protocol. Getting my point? So that's the reason it will generate the ICMP packet. Clear? So inside the ICMP packet, what are the content and how actually the ICMP packet will encapsulate? Getting my point? So we need to understand this one first. Clear? Everyone. So please focus here. Here I am writing. Okay, cool here. This is ICMP packet. Inside the ICMP packet, see very carefully, guys. I told you ICMP is the protocol which works at layer number 3 according to the OSI model. Done. Now inside the ICMP packet, first of all, what ICMP will do, guys? You guys will see ICMP header. What you guys will see? You guys will see ICMP header. Getting my point? In ICMP header, what are the content you guys will see? In ICMP header, you guys will see type field. What is type field? I hope this is visible, right? Everyone, you guys will see type field. Clear? In type field, there are two types of ICMP packet, guys. First one is called ICMP request and second one is called ICMP reply. Clear na? So this is the ICMP request. So the value will be, guys, 0x08. Please remember this one. Clear? Value will be 0x08. So 0x08 means that is the ICMP reply. Getting my point? In case of ICMP reply, the value will be, guys, 0x00. So please remember, if inside the ICMP packet, in the type field, if you guys will see the value 0x00, then you guys can understand that this is the ICMP reply. And if you see the value 0x08 in the type field, then you guys need to understand this is the ICMP request. Clear, guys? Now, after this one, the next content you guys will get here code. What, guys? You guys will get here code. Getting my point? Everyone. What are the content, guys? Everyone. Next will be, guys, code. Clear na? In code, generally the value you guys will get here 0. What is the value, guys? You guys will get the value 0. Then now, after the code, what are the content? After the code, you guys will get here checksum. What, guys? Checksum. What is the use of checksum? Who can tell me? What is the use of checksum? Please remember, checksum is a value that is used to check the error inside the ICMP header, or you can say checksum ensure the integrity. Checksum ensure the integrity. Getting my point, everyone? So basically, what is the purpose of checksum? In multiple packet, you guys will see the checksum field. The main purpose of the checksum field is the reason is basically it verify the packet was transmitted without any errors. Getting my point? That is the main use of checksum, to check everything is fine inside the packet or not. Clear, guys? Everyone. So guys, this is checksum. After checksum, you guys will see there next content, you guys will see there ID. What? ID. What is the use of ID? What is the use of ID? ID means, guys, ID basically stands for identifier. Either you can say ID and the full form of ID is here identifier. Clear na? Identifier means basically it is a unique identifier basically used to match the request and reply pairs. Again, I am telling it is used to match the request and reply pairs. Getting my point? Basically, for example, if in the real-time scenario, from the same device, if multiple pings are going, multiple ICMP packets are going, getting my point? In this case, for example, that is the destination device. If destination device will reply, how the sender device will understand this reply is for which ICMP packet? The answer is by the help of ID. For example, if this device is sending the first ICMP packet, and with this ICMP packet, identifier value is 0x001. So when this destination device will reply, the identifier value will be same. So please remember, whatever the identifier value in the request, in the reply, it will be same. Clear na, everyone? I hope you guys understand. Done. So what is the use of identifier field, guys? Identifier field is used to match the request and reply pairs. Getting my point? So by the help of identifier, basically the sender device will distinguish between the multiple ICMP request. Getting my point? So by this way, identifier is used. And the next one will be, guys, sequence number. What is sequence number? So sequence number is what? Sequence number is telling you the number of ICMP echo request. For example, if PC number 1 is sending the first ICMP packet, in this case, sequence number you guys will get 1. If PC number 1 will send the second ICMP packet, in this case, the sequence number will be 2. Getting my point? So please remember, it will be incremented by 1 with each ICMP echo request. Clear now, everyone? So what is the use of sequence number? Basically, by the help of sequence number, you can track the record of ICMP packet. If you are getting the ICMP sequence number 56, it means how many ICMP packet is already exchanged? 55 is already exchanged. That is the 56 number ICMP packet. Getting my point, everyone? So that is the use of sequence number. I hope this is clear to all of you, everyone. So guys, basically these are the information you guys will get in the ICMP header. Clear? Is this clear to everyone? Tell me. Is this clear to everyone? This is, guys, ICMP header. Now, what ICMP header will do, guys? What ICMP header will do? ICMP header or ICMP protocol will hand over this data to which layer, guys? Again, at layer number 3. This ICMP header will hand over this to where, guys? At layer number 3. And at layer number 3, which protocol is working? IP protocol is working. Which protocol is working, guys? IP protocol is working. Now, what IP protocol receive from ICMP? IP protocol receive what? Who can tell me? IP protocol receive ICMP request packet, right? Because, guys, everyone, this is ICMP request packet right now because type field is 0x08. So that is ICMP request. So IP protocol receive the ICMP request. Getting my point, everyone? I hope yes, right now. And this ICMP request packet that L3 protocol, IP protocol receive from ICMP protocol. And this ICMP request is also known as payload. Right now, payload means what? Payload is nothing. Payload means at every layer, if something layer is receiving anything from the next layer or previous layer, that is called payload. For example, that is the IP protocol. And this layer number 3, at layer number 3, there is the IP protocol, and this IP protocol is receiving some data from ICMP protocol. So for IP protocol, this ICMP request is known as payload. Clear, guys? Everyone, I hope you guys understand. Done? Now, this is the ICMP request. Clear na? And this ICMP request is also known as payload. What is, guys? Payload. Done na, everyone? Now, what IP protocol will do, guys? What IP protocol will do? IP protocol will add here what? IPv4 header. What IP protocol will do, guys? IP protocol will add here IPv4 header. Getting my point? Now, again, in IPv4 header, what are the content? In IPv4 header, what are the content? Getting my point? The first content you guys will get version. Version is, we are using the IPv4. So version will be 4. Next, you guys will get IHL. In next, you guys will get DSCP. Next, you guys will get TL, total length. Then you guys will get maybe ID. Next, you guys will get flag also. I'm telling you, these are the thing you guys will get in the IP header. Clear, guys? Now you guys will get fragment offset. Fragment offset. Now you guys will get TTL value. What? TTL value. Then you guys will get protocol number here. Then you guys will get checksum. Then you guys will get source IP. Then you guys will get destination IP. Then you guys will get data variable. Then you guys will get data variable. I hope this is clear to all of you, everyone. Yes or no? So what is this, guys? Basically, this is called IP header. This is called, guys, IP header. This is called IP header. Who add this IP header? Who add this IP header? Answer is IP protocol, right? So IP protocol is responsible to add this IP header, right? And the complete information from here to here, getting my point, is known as packet. What, guys? Packet. So please remember, at layer number 3, the complete information is known as packet. I hope this is clear to all of you. Everyone, tell me. Is this clear, guys? Everyone. This is called packet. Done. At layer number 3, that is called packet. Anyone here who do not understand? Is this clear to all of you? Guys.
Yes.
Clear na? Okay. So guys, there are multiple content inside the IP header. First one is called version. Version, I told you that is telling us the IP that we are using here, IPv4. So that's the reason version is 4 here. Clear na? Next one is, guys, IHL. What do you mean by IHL? IHL means, guys, here internet header length. What is internet header length? Getting my point? What it is telling us? It is telling us the length of IP header. What is? It is telling us length of IHL. IHL stands for, guys, internet header length. What it is telling? It is telling us length of IP, length of IP header. Clear, guys? Everyone. Generally, you guys in IHL field, you guys will see the value 5. In IHL field, what the value you guys will see here, guys? 5. What 5 means? What do you mean by 5? Anyone here who can tell me what is the meaning of 5? Again, I'm telling, in IHL field, the value you guys will get here 5. So what do you mean by 5? So please remember, in IHL field, the basically IP header specifies the length of the IP header. What is, guys? Length of the IP header. Getting my point? But please remember, in 32-bit words, it means 4 byte per word. 4 byte per word. Getting my point, everyone? So please remember like this. In IHL field, 4-bit. In IHL field, every word represent how much, guys? 4-bit. Or remember like this, one word is equal to 4 byte. This is very important. One word is equal to 4 byte. So here, what is the value you are getting? 5. And here you guys will get the value. Its range is 0 to 15. But generally you guys will get here 5. So one word is equal to 4 byte. So total value will be, guys, 5 into 4. That is how much? 20 byte. How much, guys? 20 byte. Clear, guys? Everyone. So IHL means length of IP header. And please remember, IP header length is how much? 20 byte. And that is the interview question. If anyone asks you what is the size of IP header, your answer will be 20 byte. Clear, guys? Everyone. I hope this is clear. Everyone. So total size of IP header will be, guys, how much? 20 byte. Done? Everyone. Now, next one. I hope you guys are able to see here DSCP, right? DSCP means what? DSCP stands for Differentiated Service Code Point. Differentiated Service Code Point. Clear na? So please remember, DSCP, the meaning of DSCP is it is used for the quality of services. What is, guys? It is used for the quality of services, right? And I hope you guys have some idea about the quality of services. Basically, quality of services we are using for the traffic prioritization, right? If you want to prioritize any traffic, generally we are using the quality of services. Done, everyone. Now, next one is, guys, TL. TL means total length. What is here TL? TL means, guys, total length. Getting my point? So what do you mean by total length? Total length is telling you the total size of the total size of the packet. Total size of the packet. Clear, guys? Everyone. So don't be confused here and here. This is telling you only the size of header, IP header, and that is 20 byte. But this total length is telling you the size of here. In total length, here complete packet size is included. It means header plus data, everything. So that is the total length. So don't be confused here. Clear, guys? So that is the TL. Clear? Everyone, tell me, guys. Right now, for example, I will show you in your packet, you guys will get the value 128. What is 128 in the TL field? Right? So 128 means what? 128 means the size of the IP packet is 128 byte long. How much, guys? 128 byte long. Clear? Now, guys, here you guys will see their ID. ID means what? ID means identification. ID means what, guys? ID means identification. ID means identification. Here you guys will get the value 0x0001. You guys will get the value 0x0001. What do you mean by this? Anyone? Identification means, please remember, this is the unique identifier of the IP packet. This is the unique identifier of the IP packet. Getting my point? Basically, this is used for the packet resembling. This is used for the packet resembling. Now, again, you guys have questions, sir. What do you mean by resembling here? So please understand. For example, this is one PC and that is PC number 2. If you want to send any packet from PC 1 to PC number 2, for example, the size of packet is 100 byte. So generally, if you share the complete packet, 100 byte packet at the same time with this link, and for example, if there will be a chance on this link, there will be any congestion, then what will happen? Your complete 100 byte packet will drop. Yes or no? Everyone, tell me. Right? The complete 100 byte packet will drop. It means your destination device will not receive anything. So that is the problem. So that's the reason, guys. And this is the one problem. And second problem is, if you are sending the big data over the link continuously, then there will be 110% chance there will be a congestion over the link. There will be a congestion over the link. Getting my point? So these are the disadvantages. Clear? So how can we solve this problem? Generally, in a networking, we have a concept of segmentation. What is segmentation? Segmentation means, for example, if you have a big data, what device will do? Device will break this data into small chunks. For example, that is like this: 25 bytes, 25 bytes, 25 bytes, and 25 bytes. Clear na? So that is the part 1, part 2, part 3, and part 4, like this. And then PC will share these data over the link one by one. And that is called, the process is called, guys, segmentation. Clear? Please remember, in a networking, there are two processes. First one is called segmentation and second one is called fragmentation. It means, what do you mean by segmentation and what do you mean by fragmentation? The meaning of both is same. To break your data into a small chunk. But there is a difference. Segmentation will perform at layer number 4 and fragmentation will perform at layer number 3. I hope now you guys understand. Clear now, everyone? So basically, this is the use of segmentation and fragmentation. Clear? Now, what do you mean by resembling here? Guys, first of all, tell me one thing. For example, I want, this is the PC number 1 and this is the PC number 2. If this PC number 1 wants to share one data, data is how are you doing? For example, this PC number 1 wants to share this information with PC number 2. What PC number 1 will do? PC number 1 will break this data into a small chunk, right? This is the, for example, this one. This is the part 1, this is the part 2, part 3 and part 4. Now, what PC generally doing, guys? PC will assign the sequence number. What? Sequence number on every chunks. For example, that is the sequence number 001, 002, 003, 004. Like this. Now again, what is the use of the sequence number? For example, guys, when PC number 1 will forward these chunks over the link, this is not mandatory. This PC number 2 will receive all the chunks in the sequential order. No, that is not mandatory. For example, PC number 2 receive first chunk doing. Then PC number 2 receive you. Then PC number receive how. And then PC number 2 will receive are. Now tell me one thing. Right now, does PC number 2 able to understand what is the meaning of this one? Doing, you, how, are. Do you understand what is this? No, we are not understanding. Now what PC number 2 will do? PC number 2 will check the sequence number inside the chunk. Because PC number 1 already assigned the sequence number here with all chunks. Right? So what PC number 2 will do? PC number 2 will check the sequence number. So PC number 2 will get, for doing, the sequence number is 004. For you, sequence number is 003. For how, sequence number is 001. And for our, sequence number is 002. Now what PC number 2 will do? PC number 2 will arrange all the chunks in the sequential order. Means first sequence number will be 001, then 002, then 003, and then 004. So on 001, what are the content? How? 002, what are the content? Are. 003, you, and 004, doing. And by this way, PC number 2 will understand your complete packet. Getting my point? And the overall process is called, guys, resembling. What is, guys? Resembling. I hope now you guys understand. Clear na? Same process happened at layer number 4 and same process happened at layer number 3. Getting my point? But what is the difference? At layer number 4, this process is known as segmentation, and at layer number 3, this process is known as fragmentation. At layer number 4, during the segmentation, device assign sequence number to every chunks. What? Sequence number. But at layer number 3, device assign the identification. So that is the difference. Now I hope you guys understand what do you mean by sequence, what do you mean by identification, what do you mean by segmentation, and what do you mean by fragmentation. Is this clear to all of you? Everyone? Done na? So at layer number 4, there is a concept of sequencing. And at layer number 3, the meaning is same. The work is complete same. But the name is only different. The name is identification. Done? Clear, guys? Everyone? So guys, that is the use of identification value. Clear, guys? So for every packet, there will be a unique identification value. For every packet, there will be a unique identification value. Clear na? And if anyone asks you what is the use of identification, you can say it helps to resemble the fragmented packets at the destination. At the destination. Now come to the next point. Here, guys, what? Here is that is called flag. What is this, guys? That is called flag. Clear na? So please remember, at layer number 3, or you can say at IP header, there are 3 types of flag. And I'm telling you guys, this flag is very important. Why? Because in many interviewer is asking the flag of IP header. Because maximum guys don't know, is there any flag in the IP header? Yes. Guys, at layer number 3, in IP header, there is a flag field. Fine. There are 3 types of flag. There are 3 types of flag. Fine. One is called MF, second one is called DF, and third one is called reserved. Reserved is always 0. This is used for the future uses. Clear na? Now come to the MF and DF. MF stands for more fragment. DF stands for don't fragment. MF means more fragment and DF means don't fragment. Understand? So there are 3 types of flag at layer number 3. MF, DF, or this one. Clear, guys? Everyone. Now, what is the use of MF? What is the use of DF? So please understand, if MF bit is on, it means your destination device is expecting more fragment from the sender device. For example, that is the PC number 2, that is the PC number 1. If PC number 1 is sending the data, and I told you at layer number 3, device send the data in the form of fragment, multiple chunks. Right now, everyone? Either you can say chunks, but in networking, we are calling fragment. So that is the fragment 1, this is the fragment 2, fragment 3, fragment 4, like this. Fine. So, for example, PC number 2 receive fragment 1, fragment 2, fragment 3, fragment 4, like this. So when PC number 2 will open any fragment, for example, fragment number 4. So when PC number 2 open this fragment, PC number 4 will check, is there any flag open here? Is there any flag? Now PC number 4 will see, yes, there is a MF. MF bit is on here. MF value is, for example, 1. 1 means on. 0 means off. Clear? So if PC number 2 will get the MF value is 1. Now PC number 2 will understand, oh, MF value is 1. It means I will receive some more fragment from PC number 1. Getting my point? That is the use of MF bit. MF means more fragment. It means PC number 2 is expecting some more fragment from PC number 1. Getting my point? That is the use of fragment. Sorry, MF bit. Clear? Now, DF means don't fragment. For example, PC number 2 receive fragment number 10. And in this fragment, PC number 2 will get DF bit is on and MF bit is 0. So now your PC number 2 will understand, oh, DF bit is on. It means this is the final fragment I receive from PC number 1. After that, I am not going to receive any more fragment here. Getting my point? So now I hope you guys understand what do you mean by flag at layer number 3. That is very important, guys. That is not the part of CCNA, but I told you because of your information. Clear, guys? Everyone. That is the use of flag. So there are 3 types of flag in IP header: MF, DF, and reserved. Now, next one, I hope you guys are able to see fragment offset. Fragment offset. So fragment offset, please remember one line. This indicates the position of this fragment in the original data. In the original data. Clear? So fragment offset is nothing. Fragment offset is just telling you what is the position of this fragment. And basically, it helps during the resemble process. Getting my point, everyone? Understand? This is the meaning of fragment offset. Clear? In ICMP packet, when I will show you in ICMP packet, when I will show you IP header, there you guys will get the value. Definitely there you guys will get the value 0x000. What do you mean by this? In ICMP packet, I will show you, don't worry. You guys will see their value 0x000. So it means your packet is not fragmented. Your packet is not fragmented. Getting my point? Understand? That is the meaning of this line. Clear? I hope this is clear to all of you, everyone. Now, next one is guys called TTL. What is TTL? TTL stands for guys time to live. Time to live. Time to live. Now, what is the meaning of this time to live? It is telling us maximum number of hops the packet can go. It means it is telling you the number of maximum hops. Getting my point? For example, if you are using the Windows PC, in this case, the TTL value will be guys 128. If you are using the Cisco iOS, in this case, TTL value will be 255. It means, for example, if your Windows PC will generate any packet, your packet will go maximum 128 device. For example, that is the PC number 1. And here, for example, that is the PC number 130. It means between PC number 1 and PC number 130, there will be a more than 128 PCs are there. Yes or no? But if you ping from here to here, you guys will not able to ping. Why? Because if you are using the Windows PC, the TTL value will be 128. It means if PC number 1 will generate the ICMP packet, this ICMP packet will go maximum to 128 device. If there are 130 device, your packet will not go till 130. Your packet will drop at 128. Getting my point? So guys, basically that is the use of TTL value. Understand? TTL value is just telling us the maximum number of hops that your packet can go. For example, if you are using the Cisco router, in this case, TTL value will be 255. It means in this case, your ICMP packet will go till 255 device or 255 hops. Clear? And there will be a one more rule for TTL value. Please remember, the rule is when any packet cross any L3 device like router, its TTL value will be decremented by 1. So that is the rule for TTL value, guys. Please remember this one. What is the meaning of this one? Understand. Router 1, router 2, router 3, switch PC1, switch number 2, PC2. For example, here I ping 10.1. Sorry, 10.1. For example, here the IP address is something different. For example, from here to here I am pinging. So guys, this is the Windows PC. So in this case, TTL value will be, guys, by default 128, right? Packet reach on the switch. Switch is the L2 device. So there will be no change in the TTL value, right? Packet reach on R1. What R1 will do? R1 will forward your packet towards R2. But what R1 will do? Inside the packet, R1 will decrease your TTL value by 1. Fine. So when R1 will forward the packet, TTL value will be 127. Fine. R2 receive it. R2 is also the layer 3 device. R2 also forward your packet towards the R3. Now what R2 will do? R2 again decrement the TTL value by 1. Fine. So R3 will receive the packet with TTL value 126. Fine. And R3 will again forward your value, sorry, your packet towards this switch number 2 with TTL value 125. And finally, this PC number 2 will receive your packet with TTL value 125. This is the L2 device. So this switch is not going to decrement any TTL value. Fine. So finally, your PC number 2 will receive the TTL value 125. Clear, guys? I hope you guys understand. Everyone, is this clear? So that is the use of TTL value. Clear? Now, guys, after TTL value, there is a pro. Pro means what? Pro means, guys, protocol. What is, guys? Protocol. Fine. In ICMP packet, here, in this packet, here you guys will get the value 0x01. What is the meaning of this? 0x01 means, guys, it is telling you the value 1. So please remember, protocol field is telling you what is the payload layer number 3, I mean IP protocol, receive from the previous layer. So who is the previous layer? ICMP header, right? This ICMP header, this ICMP protocol handover this header to IP protocol, right? And for this IP protocol, that is called payload, right? Na? And this payload is belongs to which protocol? ICMP, right? And so please remember, for ICMP, protocol number is 1. So that's the reason protocol number is here 0x01. Clear, guys? Everyone. So please remember, if protocol value is 0x01, it means it is representing ICMP. Fine. So here you guys can easily understand the protocol number field is 0x01. It means definitely at layer number 3, at IP protocol, there is a payload and that payload belongs to ICMP. Clear, guys? Now, again, there is a checksum. Again, there is a checksum. What is the use of checksum? It checks the error. It checks the error inside the which inside the IP header. Getting my point? That is the use of checksum. Clear na? So basically, checksum is used to verify the integrity of the header. That's all. Understand, guys? Everyone. Now that is the source IP. That is the destination IP. I hope everyone know these things. Right na? Data variable is nothing. Data variable means that is the payload. That is the payload. Understand? Are clear, everyone? Yes or no? Right? And the complete information at layer number 3, that is called packet. Clear? So complete data at layer number 3 is called packet. Fine. Now what IP protocol will do, guys? IP protocol will hand over this payload to the next layer. To the next layer. Fine. The next layer is called which layer, guys? Layer number 2. Which layer, guys? Layer number 2. Are you getting my point, everyone? Yes or no? Is this clear to everyone? Right? Yes. So layer number 2. Now, at layer number 2, at layer number 2, which protocol is working, guys? That is called ARPA. Which protocol is working? That is called ARPA. Fine. Now, what ARPA receive from layer number 3? The answer is ARPA receive packet. ARPA receive packet from layer number 3. Getting my point? And this is called what? This is called payload. Right now, for ARPA, that is payload. Clear? Now, after that, what ARPA will do? Again, ARPA will add here which header? Ethernet header. Understand, guys? Everyone. Everyone tell me. ARPA will add the Ethernet header at layer number 2. Clear, guys? In Ethernet header, what are the content? First one is preamble. Second one is SFD. Third one is destination MAC. And fourth one is source MAC. So guys, basically these are the information you guys will see at which layer? Layer number 2, Ethernet header. There are couple of more information. Type field also you guys will see there. Fine. You guys will see there FCS also. And last one, data variable. Data variable. So guys, this is called, these information you guys will get at layer number 2. At which layer, guys? Again, layer number 2. That is called layer number 2. Anyone here who do not understand? Everyone. That is called layer number 2. Anyone, any content, anyone here who do not understand? Okay, cool. So I hope everyone know about the source MAC, destination MAC, right? What is the size of MAC, guys? 48 bits, right? 48 bit means 6 byte, right? Now, there is a one more field that is called type field. There is a type field. I told you in the type field, you guys will get two values. One is called 0x0800, 0x0806. So basically this type field is telling you ARPA protocol receive one payload from this protocol. What is this payload? This is called this payload. Right now, everyone, yes or no? Right? And this payload belongs to which protocol? IPv4 protocol. So for IPv4, type field value will be 0x0800. Is this clear, guys? Everyone? But if ARPA protocol receive here one payload, and if this payload belongs to ARP protocol, in this case, value will be 0x0806. Clear, guys? Everyone understand? Guys, is this clear? Everyone, is this clear? Yes. Now, that is the thing. Now, guys, what L2 will do? What ARPA will do? Guys, the complete information which you guys are able to see here at layer number 2, the complete information is known as frame. At layer number 2, the complete information is known as frame. Understand? At layer number 3, complete information is known as packet. So don't be confused between packet and frame. Now what ARPA will do? ARPA will hand over this frame to layer number 1. To layer number 1. Clear na? So at layer number one receive the payload from ARPA protocol. And what is that payload? That payload is called, guys, frame. Right now, L1 receive the frame from L2. What L1 will do? On L1, we are using which technology, guys? Ethernet technology, right? So what it will do? It will convert your frame into bits and forward this by any medium. Either you are using the physical, either you are using the wireless, any medium you guys are using, that your frame will be forwarded in the form of bits. In the form of bits. So it will happen, guys, at layer number 1. At layer number 1, that is called bits. Is this clear? Everyone, anyone here who do not understand, please let me know. How actually our packet form? Everyone, tell me. Is this clear to everyone? So guys, basically this is the way how your ICMP packet will form. Understand? Everyone, tell me. Is this clear? I am waiting. Is this clear? Yes. Okay. For example, that is PC number 1. That is PC number 2. That is PC number 2. Now, who is sending the packet, guys? PC number 1 is sending this ICMP packet. Right now, everyone, tell me yes or no. So it means that is sender. That is sender, right? And PC number 2 will guys receive. So it is receiver. Everyone, yes or no? Right? PC number 1 is sender. PC number 2 is called receiver. Now, guys, one thing. When PC number 1 on PC number 1, you write the command ping 10.0.0.2, for example. Here IP address is 10.1, here IP address is 10.2. So PC number 1 encapsulate the ICMP packet like this. Yes or no? Right? So here packet form from top to bottom or bottom to top? Answer is from top to bottom. Yes or no? Everyone, tell me one thing. Yes or no? Right? Here our packet form from top to bottom. Agree everyone? Yes or no? Tell me fast. Right? But when this ICMP packet will reach on PC number 2, what PC number 2 will do? PC number 2 will check this ICMP packet, right? But guys, PC number 2 will receive this ICMP packet, but at which layer? Because on PC number 1 is sending this packet in the form of bits, and PC number 2 receive this bits here. Yes or no, everyone, right? So for example, that is PC number 2 here. So PC number 2 receive this one, right? So again, on PC number 2, here we are using which technology? Ethernet technology, right? So what it will do? It will convert your bits and hand over the frame at layer number 2. At layer number 2. Fine. So PC number 2 will check the layer number 2. At layer number 2, PC number 2 will check what is the source MAC and what is the destination MAC. Getting my point? What is the source MAC and what is the destination MAC? Clear? After that, PC number 2 will check what is the type field. Then PC number 2 will find the type field is 0x0800. Now PC number 2 will realize definitely with this packet, one payload is attached and that payload belongs to which protocol? IP protocol, right? So what layer number 2 will do? Layer number 2 will remove all the content which is present at layer number 2. Fine, remove these information and hand over this information, this payload to which layer? Layer number 3. Fine. So guys, basically that is the layer number 3, right? Na? So now IP protocol receive this information. We are talking about the PC number 2, guys. Okay. So now at layer number 3, what PC will check? At layer number 3, PC will check what is the destination IP address. The destination IP address, and according to the destination IP address, this PC will receive it or not. For example, the IP address is same, that is configured here, then PC number 2 will receive, otherwise no. Clear guys? Everyone? Yes or no? Done na? After that, PC number 2 will check what is the protocol number here. Protocol number it will get 0x01. It means definitely there is one payload and that payload belongs to which protocol? ICMP protocol. What layer 3 will do? Layer 3 will remove the Ethernet header with this packet and hand over this payload to ICMP. And by default, ICMP is already enabled here, guys. At ICMP receive this packet and ICMP open this packet and ICMP will find that there is a type field that is 0x08. Now ICMP will realize, this PC will realize, this is called ICMP request packet that I receive. This is ICMP request packet that I receive. Now PC number 2 will realize, oh, I received the ICMP request packet. It means I need to generate the ICMP reply. I need to generate the ICMP reply. Getting my point? So guys, basically this is the way how actually the packet is encapsulated here. Fine. Now, one more thing. When PC number 1 form the packet form from top to bottom. And when this packet reach on PC number 2 is opening this packet from bottom to top. Yes or no? Right? PC number 2 receive this one. Then PC number 2 Ethernet technology hand over this to layer number 2. Layer number 2 hand over to the layer number 3. Layer number 3 hand over to the ICMP. It means from bottom to top. Right? At sender level, what is happening? At every layer, something is attaching. Right? Na? For example, at layer number 3, ICMP header hand over this to layer number 3. So layer number 3 receive this ICMP payload and layer number 3 is adding here IP header and handing over to the layer number 2. Layer number 2 receive this payload, but again layer number 2 is adding here Ethernet header. So guys, here at sender end, at every layer something is adding, but at receiver end, at every layer something is removing. Right na? Yes or no? At layer number 1 hand over to the frame, this frame to layer number 2. What layer number 2 will do? Layer number 2 will check the layer number 2 information and remove this information and hand over this payload to layer number 3. Again layer 3 receive it. Layer number 3 check the IPv4 header remove this information and hand over this payload to the ICMP. So here at destination end, at every layer, something is detaching. Yes or no? Everyone, tell me fast. Tell me guys, yes or no, right? And at receiver end, packet is going like this. Clear? So please remember, at sender end, your packet is encapsulated. At sender end, at every layer, something is adding at every layer. And this process is called encapsulation. And on destination device, on PC number 2, something is detaching. So that process is called decapsulation. Clear guys, everyone? I hope you guys understand very well. Done? Everyone, tell me. Guys, yes or no? Is this clear to everyone? I want response from everyone. Do you guys understand?
Very clear.
Okay, cool. Cool. Now, here in simulation mode, I am on the PC number 1, command prompt. I am writing the command, guys, ARP space A. Is there any entry in the ARP table right now in PC number 1? Answer is no. I am writing the command ping 10.0.0.2. I am writing the command, guys, ping 10.0.0.2. See, at PC number 1, how many packets are there? 2 packets are there, right? I am opening the first one. This is called ICMP packet, right? Everyone, if you match at ICMP header, what are the things I told you? Type field, code, checksum, ID, and sequence number. Right? Na? See here, everyone. At ICMP header, that is called ICMP header. At ICMP header, that is the type field, that is 0x08. I told you that is the ICMP request. So that's the reason type field is 0x08. That is code, I told you 0. That is checksum. That is the ID. That is the sequence number. Fine. So what? Now, after that, what ICMP will do? ICMP will hand over this to layer number 3. At layer number 3, there is another protocol that is called IPv4 protocol. Right? So guys, this is called IPv4 header. This is called IPv4 header. Right? So see here. That is called IPv4 header. Right? In IPv4 header, I told you what are the content. Everyone, come here. Version field, IHL, DSCP, share. Version, IHL, DSCP. In IHL, what is the value? 5. I have already explained you. DSCP. What is, guys? DSCP. Who can tell me? I told you. What do you mean by DSCP? DSCP means, guys, differentiated service code. Right now, differentiated service code. A P for point. Right, everyone? Yes or no? Here, what is the value you guys are getting? Here, value we are getting 0x00. Guys, what is the value here? Here, value is 0x00. What do you mean by this? It means here, no special quality of services or any priority is assigned to this packet. Right? So right now, here in this packet, there is no quality of services. So that's the reason value is 0x00. Getting my point? Now, TL means total length. Total length size is 128. It means the total size of the packet is around 128 byte. Fine. Now ID. In ID, what is the value here? 0x0005. So that is the ID. I told you what is the use of ID. By the help of ID, basically packet, sorry, your packet will be resemble at the destination end. Getting my point? So this is the ID. Now, after that, guys, flag. What is, guys? Flag. Getting my point? Flag is 0x0. But I told you in the real-time scenario, what are the flags you guys will get? Three types of flag. Three types of flag. Reserve, MF, and DF. Getting my point? Here the value, what is the value? 0x0. This indicates that packet is not fragmented and there is no necessary to fragment the packet. Maybe the size of the packet is very less. Getting my point, everyone? Now, next one is called, guys, fragment offset. What is the value? 0x000. Right now, what is the use of this? I told you. Basically, it indicates the position of this fragment in the original data. Getting my point? And the value is here 0x000. 0x000 means your packet is not fragmented. Your packet is not fragmented. If your packet is not fragmented, then what is the use of this one? Nothing. Now, next one is TTL value. We are using the PC. And I told you by default, PC TTL value is 128. So that's the reason here 128. Next one is, guys, protocol field. Protocol field value is 0x01. Fine. Why? Because IP protocol receive the payload from ICMP protocol. And for ICMP protocol, the protocol field is 1. Right? So that's the reason value is here 0x01. Right? Next one is, guys, checksum. Checksum is used for integrity. Checksum is used for integrity. Right now. So basically a checksum basically here check the any types of error inside the packet. Getting my point? Source IP. Source IP is PC number 1 IP address, that is 10.1. Destination IP is 10.2 because you already write the command ping 10.0.0.2. Right? So that's the reason destination IP address is 10.0.0.2. Clear, guys? Now, after the IP header, is there anything? No, there is nothing. But there should be a layer 2. But at layer number 2, there is nothing. Why? Because at layer number 2, your PC number 1 don't know what is the MAC address of PC number 2. So that's the reason at layer number 2, your packet is not completely encapsulated. Fine. So that's the reason we are not able to see here layer number 2 information. Clear? When I click here OSI, see na at layer number 2, when I click on the layer number 2, see, please read this one. Please read this line. When you read this line, what is the information? The next hop IP address is unicast. The ARP process looks it up in the ARP table. Yes, I told you. Right now, your PC will check the ARP table. And when your PC will check the ARP table, your PC will not find the destination device, destination IP address, MAC address in the ARP table. You are pinging 10.0.0.2. But I already show you, is there any entry in the ARP table? No. Your device, your PC number 1 didn't find the MAC address for this 10.0.0.2. Clear? So that's the reason your layer number 2 is not completely encapsulated. Fine. So now what PC number 1 will do? PC number 1 will give this responsibility, not actually PC number 1, at layer number 2. Which protocol is there, guys? ARPA. Right now, at layer number 2, which protocol is there? ARPA. Right? So ARPA will give this responsibility to which protocol? ARP protocol. Getting my point? Now this is the responsibility of ARP protocol to find out what is the destination device MAC address. Is this clear, guys? Everyone, anyone here who do not understand, please let me know. Is this clear? Is this clear? Everyone, done? Yes. Right? So that's the reason this packet is going to hold here, right? Because PC number 1 don't know what is the MAC address of PC number 2. Fine. Now PC number 1 will generate which packet, guys? ARP packet. Which packet, guys? ARP packet. Clear, guys? Anyone here who do not understand, please let me know. Is this clear, guys? right? Okay. Now come here, guys. R packet. R packet. Now, in R packet, there are some content. In R packet, there will be a some content. Right now, first of all, there will be a guys ARP header. Same like a ICMP. At ICMP, there will be a ICMP header. Similarly, in case of ARP packet, there will be a ARP header. Fine. In ARP header, what are the content generally you guys will see? First one, guys, you guys will see hardware type. Hardware type. Second, you guys will see protocol type. What? Protocol type. Next one will be, guys, HLEN. Next, you guys will get PLEN. Next, you guys will get opcode. Opcode. Next, you guys will get source MAC. Next, source IP. Next, target MAC. Next, target IP. So, guys, these are the information you guys will see in the ARP header. In the ARP header. Anyone here who do not understand? Is this clear? And guys, generally ARP header works at which layer? Who can tell me? According to me, it works at layer number 2.5. Maybe in some book you guys will see layer number 2, layer number 3, but according to me, it works at layer number 2, not 2.5. Now, what ARP will do, guys? After that, ARP will hand over this to the next layer. Now tell me, guys, the next layer will be the layer number 3 or layer number 2. Who can tell me? Next layer,
Number 2.
Layer number 2. Exactly. Our packet will go every time from top to bottom. No, not bottom to top, because whenever device is encapsulating the packet, for example, that is the device and that is the device. So guys, basically this device is encapsulating the packet, right? So during the time of encapsulation, your packet will go from top to bottom. And at the time of decapsulation, packet will go bottom to top. Understand, everyone? Now, what ARP will do, guys? ARP will hand over this packet to layer number 2. Which one, guys? Layer number 2. At layer number 2, which protocol is there, guys? ARPA. Fine. What ARPA receive? Who can tell me? ARPA receive the payload from ARP protocol. Right now, that is ARP header, or you can say payload. Done? Everyone, tell me yes or no. Right? Now, what layer number 2 will do? ARPA will do. ARPA will add here which header? Again, same Ethernet header, same content. Preamble, then SFD, then destination MAC, then guys, source MAC, then type field. Yes or no? Everyone. Tell me, guys, yes or no? Right now, see na, at destination, at layer number 2, source MAC, destination MAC, type field, and last one is FCS, frame checksum. So guys, basically that is the information you guys will get at layer number 2. And layer number 2 information is known as, guys, what we are calling it? Frame. We are calling it frame, right? What L2 will do? L2 will hand over this to layer number 1. L2 will hand over this to layer number 1. At layer number 1, what will happen? We are using again Ethernet technology. What it will do? It will convert your frame into bits and forward this y physical medium. Forward this to physical medium. Getting my point? Everyone, anyone here who do not understand, please let me know. Is this clear, guys? Everyone understand? Guys, yes or no? Right? Okay.
Yes.
See, in our packet, you guys will see some content. What is this? Our hardware type. In hardware type, you guys will get the value 0x0001. Here you guys will get the value 0x0001. What do you mean by this? Guys, nowadays we are using which hardware technology? We are using nowadays Ethernet technology. We are using nowadays Ethernet technology, right? So 0x0001 indicates, guys, Ethernet technology. Getting my point, everyone? So that's the reason here you guys will get the value 0x0001. Now here is protocol type. What is, guys? Protocol type. What do you mean by protocol type? Anyone here? What do you mean by protocol type? Anyone? Tell me one thing. On this device is generating the ARP packet. But why? Your answer will be, sir, on this device, this PC don't know the MAC address of 10.0.0.2. Am I right? Everyone, yes or no? Right? This should be the answer. The answer is this sender device don't know what is the MAC address of this IP. Right na? So for this reason, this PC is generating the ARP packet. Fine. Either you guys can think like this, or either you guys can think like this, कि basically here device is generating the ARP packet for this IP address to solve the problem with this IP address, right? So directly or indirectly, this ARP is for IP address, IPv4 address, right? So for IPv4, protocol type is, guys, 0x0800. Understand, everyone? Yes or no? Right now, 0x0800 stands for IPv4. And this ARP, this PC generate the ARP to solve the IP address problem. Because this PC have 10.0.0.2 IP, but this PC do not have this IP MAC address. Getting my point? So this ARP is for this IP address. So protocol type will be, guys, 0x0800. Now, next one is, guys, HLEN. HLEN is nothing, guys, hardware length. HLEN means, guys, hardware length. Clear na? Hardware length. Here you guys will get the value 0x06. 0x06. It represents 6 byte. 0x06 means 6 byte. So hardware length is nothing. This is telling hardware address size. Now, what do you mean by hardware address? Either you can say hardware address or either you can say physical address. Both are same. Or either you can say physical address or either you can say MAC address. This is also same. Yes or no, everyone? Right now? So HLEN, hardware length, it represents the size of MAC address. Who can tell me what is the size of MAC address? MAC address size is 48 bit. MAC address size is 48 bits. And here the value you guys are getting 6 byte. And if you convert 6 byte into the bit, 6 into 8, that is 48 bits. Understand, guys? Everyone, yes or no? So HLEN means hardware length, and it represents the size of MAC address. Now, PLEN. PLEN means, guys, protocol length. What is protocol length? Understand, guys? Protocol length. Clear na? So protocol length means what? Who can tell me? It represents the size of protocol. It represents the size of protocol address. And I told you now, what is the protocol type here you guys are using? 0x0800. It means it represents IPv4. So if protocol type is IP, then protocol length will be size of IPv4. Yes or no? Everyone, tell me. Right na? And here you guys will get the value 0x04. And when 0x04 means how much byte? 4 byte. And if you convert into the bit 4 into 8, that is 32 bit. And please remember the size of IPv4 is how much? 32 bit. Is this clear, guys? Everyone, yes or no? Clear? Everyone, is this clear? So PLEN means protocol length. Clear na? So here we are using protocol type IPv4. It means IP protocol. Right na? Are you understand na? So type is 0x0800 and the size is 32 bit. So either you can say 32 bit or either you can say 0x04. Now guys, next one is called opcode. Next one is called opcode. Opcode means what? Guys, opcode is telling us the type of ARP packet. Generally, there are two types of ARP. First one is ARP request and second one is called ARP reply. Now the question is, sir, how can we identify that is the ARP request and that is the ARP reply? The answer is by the help of opcode value. By the help of, guys, opcode value. Clear na? So guys, in opcode value, you guys will see two types of value. If you guys will see the value 0x0001, it represent that is the ARP request. If you guys get the value 0x0002, it means that is the ARP reply. Understand, guys? So opcode is telling us the type of ARP packet. Fine. If the value 0x000, then it will be ARP request. And if the value will be 0x0002, then it will be the ARP reply. Clear? Source MAC, I hope everyone know. Right? Source IP, everyone know. Target MAC or destination MAC, both are same, right na? But in ARP packet, you guys will get the term target, not destination. Clear na? So don't be confused. Clear? I'm not going to explain you these things because I hope everyone understand these things. Clear, guys? Source MAC means this sender device MAC address. Source IP means sender device IP address. Target MAC means destination device MAC address. Clear na? And target IP means guys, destination device IP address. Are you clear, guys? Everyone, yes or no? Everyone, yes or no? Right na? Now, there is one more thing you guys need to understand. Here's in source MAC, you guys will get, for example, MAC address of this PC is 0A. Source MAC, you guys will get the value 0A. Source IP, here you guys will get, for example, IP address is 10.1. Source IP, you guys will get this one. For example, if you are pinging 10.2, for example, IP address of this PC is 10.2. So target IP, you guys will get here 10.2. Fine. But target MAC, guys, still this device don't know the target MAC, this device MAC address. If this device already know what is the MAC address of this PC, then why this device generate the ARP packet? There is no need of generate the ARP packet because here ICMP packet was hold. Why? because this device don't know what is the MAC address of this PC. Getting my point? But again, in the R packet, there is a field target MAC. What are the content? Guys, please remember, in target MAC field, you guys will get the value 00000. And it represent this PC don't know what is the MAC address of this device. So that's the reason target MAC will be, guys, 0000. Is this clear, guys? Everyone, yes or no? Understand? Now it will hand over to the layer number 2. Layer number 2, I already explain you, right? Only one thing you need to understand. Everything will be same. Here in the type field. In type field, what is the value you guys will get? Type field means, type field is telling you at layer number 2, ARPA receive this payload from which protocol? So guys, ARPA receive this payload from which protocol? ARP protocol. So here in type field, you guys will get the value 0x0806. Getting my point? Yes or no? Right now? I hope you guys understand. Clear? Anyone here who do not understand? But here, in case of ICMP packet, what was the type field? Who can tell me? What was the type field? Guys, what was the type field? Let me open it. See here. In ICMP, oh, here layer number 2 is not there. So we are not able to see. But at ICMP, there was 0x0800. 0x0800. Yes or no? Here in the type field. Because at ARPA will check, I receive this payload from which protocol? IP protocol. So type field will be 0x0800, right? But here, in case of ARP, here ARPA is receiving this payload from which protocol? ARP. So value will be 0x0806. And the destination MAC will be, guys, FF. That will be broadcast. Clear now? And I already told you, if you guys remember, ARP request always be broadcast. ARP reply always be unicast. Clear, guys? So guys, basically this is the thing you guys will see in ARP header. Clear? So this is the ARP packet. Let me open it. See, guys, in ARP packet, I hope you guys will get everything what we discussed here right now. Please see. In our ARP header, I told you hardware type. Hardware type is 0x0001. It represents the Ethernet. Protocol type is, guys, 0x0800, because we are generating this R for the IP protocol. Right na? Yes or no? Now that is the hardware length. The value is 0x06. It means it represents the 6 byte. 6 into 8, that is 48 bits. And the size of MAC address is 48 bits. Now PLEN. PLEN means, guys, protocol length, right? We are using this R for IP protocol, right? So the length is 0x04. 0x04 means 4 byte. If you convert into the bit, 4 into 8, that is 32 bit. Opcode value is 0x0001. It means that is the ARP request. That is the source MAC address. That is the MAC address of this PC. 60dB. See here, 60dB. Source IP address means PC number 1 IP address. Target MAC is, I told you, na, 0000. Why? Because PC number 1 don't know what is the target MAC address. So that is 0000. Target IP is PC number 2 IP address. That is 10.0.0.2. Now, ARP hand over this packet to layer number 2. That is Ethernet, right? So the layer number 2, there is a protocol. Which protocol? At layer number 2, that is layer number 2. At layer number 2, there is a protocol ARPA. What ARPA will do? ARPA will add the Ethernet header. In Ethernet header, that is the preamble, SFD, destination MAC is FFF. That is the source MAC address. That is the type field. In type field, what is the value? 0x0806. Why? Because ARPA received this payload, right? and this payload belongs to which protocol? ARP. So that's the reason value is 0x0806. Fine. That is the FCS value. Clear, guys? Everyone? Yes or no? Understand? Now see, it forward the ARP packet. Fine. This ARP packet reach on the switch. This ARP packet reach on the switch. What switch will do? Open this. I told you switch maintain one table. So MAC address table. See, immediately switch, open this packet, immediately switch inbound. Guys, there are two things, inbound and outbound. Inbound means the packet switch receive, and outbound means this is the packet switch going to forward. Fine. So come to the inbound. Come to the inbound. So guys, in inbound, switch will check what is the source MAC address. What is the source MAC address, guys? Please see very carefully. What is the source MAC address? 60 dB, right? And switch is receiving this packet on which interface? Fast Ethernet 0x1. So switch immediately learn on fast Ethernet 0x1. I am learning automatic this MAC address, and this port is by default is in VLAN number 1. So switch perform here learning task. Clear? Understand? So first task switch will perform, that is learning. Now after that switch will take the forwarding task. What, guys? Forwarding task. Fine. What switch will do? Switch will check. Switch will check. Switch is the layer 2 device, right? Na? So switch will check. What is the destination address? Destination address is FFFF. That is broadcast. That is broadcast. Now what switch will do? Switch will perform the broadcasting. Switch will perform the broadcasting. Yes or no? Everyone. Yes, na? Switch will perform the broadcasting. So switch will forward this packet through all the interface except those interface on which switch receive this packet. Switch receive this packet on this interface. So except this interface, which will forward this packet here, here, and here. Clear, guys? Everyone? Yes or no? Understand? Now, when you open the outbound, where is the packet? See, that is the inbound, and here outbound. Is there any difference in the inbound and outbound? There is no difference in the inbound and outbound, guys. There is no difference. It means switch is not going to change anything inside the packet. Fine. Switch is just forward the same packet, right? See, switch forward the packet to every devices. Fine. These PC open the packet. These PC open this packet, and this PC will find what is the target IP address. Target IP address is 10.0.0.2. 10.0.0.2. Then this PC will realize this packet is not for me. My IP address is 10.0.0.3, not 2. So these PC drop this packet. 10.0.0.3 will drop this packet. Getting my point, everyone? Yes or no? Clear? This PC will drop this packet. ARP A. See, this PC also do not maintain the entry in the ARP table also. If you guys remember, same thing I already explained you. If you guys will receive any random call, you guys are not going to save that number in your contact, right? In the same way, PC number 3 is not going to save this MAC address, right? But this PC receive it. See here, what this PC will do? This PC perform the learning task. ARP A. See, this PC learn the MAC address. Open this packet. This PC open this packet. In this packet, first of all, this PC will check. Open the layer number 2. At layer number 2, the destination MAC is FFF. It means this PC will realize that this packet is for everyone. It means this is for me also. So this PC will receive it. There is no problem at layer number 2. Getting my point? Yes or no? Then this PC will check what is the type field. Type field is 0x0806. Now this PC will realize Definitely in this packet, there is a one payload and that payload belongs to ARP. Immediately this PC will hand over this packet to ARP. Fine. Now come to the ARP. In the ARP packet, this PC number 2 will check what is the source IP address and what is the source MAC address. Source IP address is 10.1 and source MAC address is this one. Immediately PC number 2 will add these two entry in which table? And in which table? ARP table. See, getting my point? Yes or no? Understand? After learning task, this PC number 2 will check. This PC number 2 will check what is the op code. What is the op code? Op code is 0x0001. PC number 2 will realize, oh, this is the ARP request. It means I need to forward, I need to generate the ARP reply as well. Getting my point? Yes or no? Understand? Now come to the outbound. Outbound means this is the packet PC number 2 is going to generate. Getting my point? Again, what PC number 2 will do? PC number 2 will encapsulate the packet. At layer number 2, that is same. Fine. Source MAC address, that is the PC number 2 MAC address. Destination MAC address, that is the PC number 1 MAC address, right? Because now PC number 2 already know what is the MAC address of PC number 1, right? So PC number 2 is able to find destination MAC address. Clear? Type is, guys, again 0x0806. Why? Because here PC number 2 is going to attach ARP packet. Fine. Hardware is same, protocol is same, right? This one will be same, this one will be same. Opcode is what? 0x0002. It means that is the ARP reply. That is the ARP reply. Getting my point, everyone? Yes or no? Clear? That is the source MAC address. That is the source IP address 10.0.0.2, PC number 2 IP address. And this is the target MAC address. It means that is the MAC address of PC number 1 and target IP address is this one. Fine. And guys, this is the unicast packet. That is the unicast packet. Packet reach on switch. What switch will do? Again, same thing. Switch open this. Switch perform the learning task. Switch perform the learning task and make the entry in the MAC address table. See, now how many entries are there? 2 entry. How many entries are there? 2 entry. Getting my point? Switch will check. On fast Ethernet 0x4, I am receiving one automatic packet. So type is dynamic. And in this packet, source MAC address is 12A4. Fine. And the VLAN is 1. Switch learn this. Now after that, what switch will do? Switch will check. Switch will check. What? Switch will check at layer number 2. What is the destination MAC address? Destination MAC address is 60dB. Now switch will check it's again which table? Switch will check again, guys, which table? MAC address table. And in the MAC address table, switch will find, oh, 60dB. I know. 60dB. I know. 60dB is present on which interface? Fast Ethernet 0x1. Immediately, switch will forward this packet. Why? 0x1. Switch, see here, inbound and outbound. There is no change. Switch do not perform any types of change in the packet. Switch just forward this packet through this one. Packet reach here. Fine. What PC will do? PC open it. This PC will open it. And this PC will make the entry in which table? ARP table. In which table, guys? ARP table. Fine. Now see the ICMP packet, guys. In ICMP packet, I hope now you guys are able to see. Now Ethernet header is there. Now we are able to see Ethernet header. Why? Because now destination address, this PC know what is the PC number 2 MAC address. PC number 2 MAC address. Getting my point, everyone? Yes or no? Clear na? Previously we were not able to see because at that time destination MAC address was missing. But now we are able to see destination MAC address. Fine. So now this PC is able to encapsulate the packet completely. Fine. Everything is same. There is no change. Everything is same. Only this PC add the destination MAC address here. Clear na? After receiving the ARP packet. Clear? After exchanging the ARP packet. Clear? What PC number 1 is doing now? See, PC number 1 is send the ICMP packet. ICMP packet reach on switch. switch open this ICMP packet, switch will check in ICMP packet, ICMP header, IP header. Switch is not going to open your IP header, not going to open your ICMP. Switch is a layer 2 device. Switch will check what is the destination MAC address. 12A4. Now switch will check its MAC address table. Do I have 12A4? Yes. 12A4 I know. On which interface? Fast Ethernet 0x4. What switch will do? See here, inbound, outbound. Is there any change? No change. There is no change. What switch will do? Switch will forward this packet by 0x4. See, 0x4. PC number 2 receive this ICMP packet. Open it. When you see this is the ICMP packet, PC number 2 receive. Again, what PC number 2 will do? PC number 2 will receive the Ethernet. At Ethernet, PC number 2 will check what is the destination MAC address. That is, it means PC number 2 will realize, oh, this is my MAC address. PC number 2 will accept this packet at layer number 2. Now PC number 2 will check what is the type field. Type field is 0x0800. It means in this packet definitely there is a IP protocol or IP payload is there. Immediately PC number 2 will hand over this packet to IP protocol at layer number 3. Fine. So this is the IP payload, right? And now IP protocol receive this IP header. At layer number 3, what PC number 2 will do, guys? PC number 2 will check. PC number 2 will check what? First of all, what is the destination IP address? Destination IP address is 10.0.0.2. It means, and my IP address is also 10.0.0.2. PC number 2 will accept this packet at layer number 3 also. Accept this packet at layer number 3 also. Now PC number 2 will check what is the protocol number. Protocol number is 0x01. Now PC number 2 will realize, oh, definitely with this packet, ICMP payload is there. Which is ICMP payload is there. Fine. What PC number 2 will do? PC number 2 will hand over this packet to ICMP. Fine. And in this packet, what ICMP will do? ICMP packet is already there. ICMP packet, open it. ICMP packet will check. What is the type field? Type field is 0x08. It means that is the ICMP request. I need to generate the ICMP reply. I need to generate the ICMP reply. Now come to the outbound. See, in outbound, this is the ICMP reply. See here, at layer number 2, that is the source MAC address, PC number 2, destination, PC number 1, type field is same, IP, source IP address is PC number 2 IP address, destination IP is PC number 1 IP address, protocol is ICMP. Now come to the ICMP. In ICMP, what is the type field? 0x00. I told you 0x08 means that is the request and 0x00 means that is reply. That is ICMP reply. That's the reason type field is 0x00. Getting my point, everyone? Yes or no? Everyone tell me. Yes or no, right? Now, one more thing. Come to the inbound. In inbound, first of all, see here, what is the ID? ID field is 0x0003. What is the use of ID field? I told you. By the help of ID field, device is sending or device is generating the reply for the exact request packet, right? So this PC received the ICMP packet with ID 0x003. It means this PC needs to generate the ICMP reply for the same ID. So that's the reason. In outbound packet, also see the ID field is 0x003. And sequence number is also same. Sequence number is 005 and sequence is also 5. Getting my point, everyone? So this is the ICMP reply. So this packet generates the ICMP reply. Packet reach on the switch. Switch again open this packet. Switch will check. This is the packet switch receive. Switch will check. What is the destination address? 60 dB. Switch will check. Do I know 60 dB? Yes. 606B I know. At which interface? Fast Ethernet 0x1. Fast Ethernet 0x1. Switch will forward this packet to PC number 1. And PC number 1 will accept this packet. PC number 1 will accept this packet. Come here at PC number 1. See, Communicate. PC number 4, how many packet? Sent 4 packet, receive 4 replies, 0% loss, 100% successful. Getting my point, everyone? Even you can check the ARP table. Yes. Now PC number 1, no, what is the destination device? MAC address also. It means after the exchange of ARP, PC number 1 already install the information, MAC address information of PC number 2. So guys, that is called packet flow in the same subnet. And I hope everyone understand very clearly packet flow in the same subnet.